Tune into this week's Xamarin Show where I have my good friend Dean on to talk about best practices for async await. You do not want to miss this, so tune in. Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and today I have my favorite person in the entire world, Dean, with me. How's it going, Dean?
Good. How are you?
I'm obviously absolutely fantastic. Now, people may not know who you are because this is your very first time on the show, and I'm really excited because we have a brand new micro series for best practices. And Dean, you are an expert in everything, but tell everyone a little bit about yourself.
Yeah, I'm Dean from the Microsoft Mobile Customer Advisory Team. We work with customers to help them figure out Xamarin best practices, how to improve their apps, how to get a good dev loop going, and all in general have a great experience with Xamarin.
Yeah, that's awesome. I mean, it's really great because we have a great platform, but it's so easy as a developer to kind of get yourself into trouble. I mean, it's not your fault, but sometimes you just write some bad code. I write bad code all the time, Dean.
Yeah.
And I was talking to Alex, big boss man Alex, who will be on the show soon to talk about HTTP client. And we were just like, man, I see sort of a lot of the work that you're doing with the team. Let's do a best practices series. So we're going to have a whole series of this. This is the first video, async await, which I think honestly is one of those topics that I feel like I know a lot about, but then I don't. And then I get people's code and I'm like, I think you're doing it wrong, but maybe I'm doing it wrong and we're doing it wrong. So what do you see out in the field with async await?
Yeah, so that's what I'm here to clarify today. So there are a lot of different ways to use async await, and that's kind of part of the problem, right? It's hard to understand what each different method, each different field is on the tasks, what all the different keywords are, and how they differ. Because sometimes they're very similar, and they were only created out of necessity and efficiency, right?
Got it.
Yeah.
I remember when I started with Xamarin, I didn't even have async await. Now, I did have tasks, but I would always like continue with.
Yep.
And I was like, okay, I get it. Like I do this thing, and then I'm like, when you're done, do this. But sort of that async await, it always felt magical because my code got like so much cleaner, and I was like, just await, just await, just await. And I didn't really think about what it was doing.
Yeah, and it just works, right? Until it doesn't.
Well, let's get into it. So you told me you have like a bunch of things that are not so good that people might be doing, right?
Yeah, so I have a sample application. We'll have a link to the repo. And in this app, we just have a bunch of different examples. So on the left-hand side, we'll have the bad examples of what we see out in the field, what we see common mistakes are, pitfalls, and on the right side is how to fix them.
Okay, perfect.
Yeah.
I like that also, by the way, because it's like, here's bad code, here's good code.
Yep, exactly. Just make it digestible, and then also to see the contrast and see what actually happens when you run it, right?
Oh, perfect.
Because a lot of times we look at Stack Overflow or looking at a sample, and we kind of contextualize in our head. But when we run it on the device, it's really hard to follow if you don't do it.
Got it.
Yeah, so let's just jump right in. So for the first page, what we have here is your typical task. So let me just explain the app a little bit.
Sure.
So we have a task service that has this main method, which is get string with task run async.
Okay.
And what this is it's just a wrapper around a task. So we'll see this is the main task. And it's just a wrapper so that I can print the different task statuses to the console or to the app itself. So all it's doing is running a delay internally. And then we'll see the different task statuses come up on the screen.
Gotcha. So this is sort of like just your helper method that you're using
to illustrate.
And this is returning a task of string. So this might be very familiar if you're using HTTP client.
Exactly.
Get string asynchronously. You would call this get string with task run async, and then you would await on that, right?
Exactly.
In general. So very similar, but you're also passing in a bunch of arguments here, like delays and cancel. You're going to go into those?
Yeah, so there's a bunch of default parameters, but I did add those to kind of show the different examples. So we have flexibility. So some of them are just passing in an action so that we can run something after the delay and so on.
All right, perfect. Cool. Let's go.
So we'll get into that as we go. All right, so the first one is just invoking a task. So once we have that task, so what the method returns is just a task string that we talked about.
So what that is saying is, hey, I'm going to go do some work, and when I'm done, I will return a string.
Exactly.
And the whole idea of a task and awaiting on it is long-running processes. And I want to make that clear because that's why you make a RESTful service call with HTTP client because that network request might take a few seconds, and you don't want to block your UI thread.
Exactly.
So you're awaiting. It's like a promise coming back. Like, I'm going to go do some work. When I'm done, then continue on. And that way it doesn't block your call. Right? And that's your UI thread. And that's why it's important here. So when I call this method that you have, it's going to return a string at some point.
Correct. So this is the bad way to start with. So we'll see we're invoking the method. But then we're calling .result at the end of it.
Oh, .result.
Yeah.
I wrote a whole blog post, by the way, on stop calling .result.
Yep,
so why is this bad? I don't understand.
So what .result is it'll wait for the result of the task. And when that happens is when we call it, it waits. If the task hasn't completed, it just waits in line. So we'll just actually stick here and then just wait till the result comes back. And then we can continue execution.
So if that takes 10 seconds, you'll have locked your application completely for. So this is synchronous. It basically turns an asynchronous method into a synchronous method.
Exactly, and you never want to do that.
No.
So let's take a look. If we click this, it'll run for 2 seconds, and then it suddenly pops up. So you'll see while it's running, we can't open the menu or anything. Oh, that was really fast. I think it's 1 second now.
But you saw there was a delay there.
Yeah, but you see the delay. You see the button animation kind of sticks there.
That's the best way to do it, right? When you click on something, it should continue, but that blocked that button from even finishing its animation.
Yeah, and you don't want that. And that was just 1 second. So like you said, if you have 10 seconds, user's going to delete your app just like that.
Yeah.
All right, so let's look at how to fix this, right? So this is the one-liner that we have. All we do is call await on the task, and we get the result, same as before. But the end behavior is, it just runs like that, and the task completes asynchronously. We can still use the app. We can even run it multiple times. So if you just click on this a bunch, it'll all complete just and return and print out your completion.
And if you try to do it on the bad task invoke?
You can't even.
It won't even let you do it.
Won't even let you do it.
I think I might have just broke your
app. It might have deadlocked,
That's what's also, there we go. It finally happened. So, but that is a bad user experience.
Exactly.
Right? So
you never want that.
So you dropped the .result and then you used await.
Yep.
Right? Is that what you did there? Okay.
Simple stuff.
Got it.
All right. So moving on to the next one. Let's collapse this down. Next one is multiple tasks. So once you figured out that you can await tasks, the next thing I see is people await tasks separately. So if you have like 3 REST services endpoints that you need to call, and they want to call them asynchronously, right? So they just await first one, await second one, await the third one, and you know what happens.
You're awaiting and awaiting and awaiting.
Exactly.
And you're not going to get to the end until everything is done.
Until everything is done. So let's take a look at that. We have our awaits in a for loop.
Okay.
Let's just run it. So we'll see the first one go, second one, third one, and so on.
And that doesn't look too bad because you're awaiting, so you're not locking your UI, but you're 1, 2, 3,
exactly.
4. So that's the problem.
Yeah.
Gotcha.
And these tasks are just 1 second, just to illustrate. But if you download the code, you can change the values and see what it feels like in real time.
Gotcha.
So let's take a look at the fix. So the fix is to actually keep the tasks in a collection. In this case, I'm putting them in an array. And then we can call task.whenAll on the whole collection.
And what does when all mean? What does that mean?
So when all means that this task will only return once all the tasks are done. So when a task is done, that means it either completed, or it was canceled, or it's faulted, so it threw an exception.
Okay, so previously we were taking these tasks and we were firing, waiting, firing, waiting, firing. So now what you're saying is you're going to fire all of them. And then when done, come back.
Exactly.
Oh, that's a thing of beauty, right?
Yeah.
You could be uploading a bunch of files at once, and then the task here, it's going to figure out the threading, all this stuff for you automatically. Oh, beautiful.
Yeah. And the tasks can complete separately. So some of them, if some of them come back early, that's fine. It'll just complete once the last task comes in.
Oh, nice. Okay.
Yeah.
Cool.
So
what does that look like?
Let's take a look. So for the previous one, it took 5 seconds, we can see here. But if we run them with task.whenAll, we'll see that they all fired off, and then they all completed together.
Because they all ran for a second, so they're all done.
Exactly.
So that's even just literally a 4-second improvement. Because guess what? These mobile devices can handle all that, right? Like, you have the bandwidth. Stop choking your app, kind of. Cool. Nice.
Yep. Yeah, so that's a really good improvement. We see that a lot. Next, let's look at returning tasks.
Okay.
So this is kind of tricky. We looked at, let's look at the good one first, because this is kind of tricky.
Okay.
So in our good example, we returned a string. We returned a task string.
Yep.
So what we actually returned at the end is a task itself. I'm sorry. This task.run task.
Yes.
So this is the task, and then this is just all the kind of harness code to print out the task statuses. And then at the end, we just return the task string.
Okay. Yeah.
Okay. So this is what we've been doing all along. So I don't have to show the good sample. But for the bad one, we're calling a different method, which is here, await string with task run async. And all that is it's the previous method, but we just return await instead of returning the task directly.
I see.
So we're adding.
So this here is just like a helper method that might be doing some stuff, but we've added an async and await keyword here because we thought we had to.
Exactly.
Okay.
Because so the normal case for this is if this is like a library that we're using, and it's an async library. Sometimes developers kind of think, oh, because it's async, we have to await. So then they'll just return await. But what you can actually do is just return the task like we did earlier, and that's actually faster because we don't have to await twice. So now there's a wait in between, which does context switches and all this stuff under the hood.
Yeah.
That it's not much if you're just running a little bit, but it adds up.
I see. So the main problem that we're seeing here in general is there's already a task, and then you might have another method that is returning a task that you want to await on, because you got to have a bunch of gobbledygook in here too.
Yeah, oh yeah.
But there's no like context. There's no is busy. There's no anything.
Yep.
But you're awaiting on it because you thought you had to. So don't await.
Yep.
And what's this context switching that you're talking about? So
Oh,
you're
yeah.
saying this is generating other extra code, kind of?
Yeah, so under the hood, this is generating extra code that's unnecessary. So we'll get into the context, but what it basically is with Xamarin apps, there's a main thread, which is the UI thread, and then there's a bunch of other threads, which depends on what device you're running on.
Gotcha.
So think of the different threads as a different context, and you always want to run off of the main thread.
Gotcha.
And that's what awaiting does for us.
I see.
Where .result actually ran on the main thread.
Okay, gotcha. Cool.
Cool. So for this one, this actually shows a big improvement once we run like up to 1,000 tasks. But it takes a while, so on air, let's just run 100 and see what happens. Oh, I'm sorry, it's not that one. It was task return, this one. Okay, so we're running 100 tasks. And you'll see that even though we're doing task.whenAll, just like before, they're not actually all firing off at once. Because .NET's smart enough where it knows like, hey, I can't run these many in parallel, so let me just chunk them off and run them when it's useful for me and to be performant.
And I like also that you're scrolling through and it's firing off more,
Yeah.
but your UI is responsive.
Exactly.
So it took 13
Yep,
seconds.
13 seconds.
Okay.
So if we do task.return await on the task.
So this is the one where you're adding an extra await.
Adding extra await.
And also we're kind of see that they're kind of chunking a little bit. They're not
Differently,
chunking
right?
here then,
Yeah,
because
they're kinda
you're
different.
awaiting and then also chunking them.
Yeah. And then we'll see 9 seconds. So again, the difference is very minuscule for like, this is 100 tasks, but I tried with 1,000 and it's almost twice the time.
Gotcha. Awesome. So what we saw, kind of you ran bad task and then the good task. And the bad task actually was 10 seconds compared to 6 seconds.
Exactly.
So pretty good. If you did that, like you said, over 1,000, that would be dramatic.
Yep.
Yeah.
Yeah, and it adds up. So the magic of tasks make it almost too easy for developers to abuse it, right?
Yeah.
It's like if you have a power tool, it's too powerful. So you have to kind of control yourself and understand it.
And the compiler's smart, but we just need to kind of help it from time to time, right? Just be like, hey, like, we can help you out a little bit when you actually need to await on it.
Exactly.
Yeah. Cool.
So let's go to the next one, which is bad threading practices.
Okay.
So we talked about context before. So this is where I'm going to illustrate. So when we run a task, well, before that even, when we hit a button and run the command, it actually executes on the main thread.
Yes.
So once we await the task, what does it continue on afterwards? Is it still the main thread? Is it a different thread? So developers don't think about this, right? It's like, well, it came from the main thread, maybe it's still, or sometimes they don't even think about the context, because it's like, it's await, it works, it's just beautiful, it runs asynchronously. But then everything after that, you have to be mindful of where it runs. So in this case, we have a thread sleep to simulate a long-running calculation or some sort of download, image processing, whatever it is. And it's happening after an await, so sometimes people think they're safe. But what happens is execution returns back to the main thread, and then this runs on the main thread. So let's take a look at that.
I see. Okay, gotcha. So in this instance, when we call out to this service, it's going to start on the UI thread and actually await, do stuff in the background, come back onto the main thread, and then we're thread sleeping. But you may think it's on a background thread.
Exactly.
But it's not. Okay, cool.
Because the await was on a background thread.
Got it.
So let's take a look.
Yeah, let's take a look.
Yeah.
So it started, it's created the task.
Yep. And then it was sleeping. Okay, so this is 5 seconds. We can actually see that the app's totally unresponsive.
Oh, so that thread, which is 5 seconds, has completely locked the app. Very similar to like a result almost.
Exactly.
Gotcha. And you were locking that thread.
And we didn't even use it result. We used await. Yeah. So
Gotcha.
it's tricky in that way.
Yeah.
So the way to fix this is to actually use the magic keyword configure await false.
This is always tricky. This one's tricky, and it always scares me a lot, so please explain.
Yes, so configure await, by default, a task will have configure await true. And that just means return on whatever context was calling it, which was the main thread, right? So when we say configure await false, we'll say don't return to the thread that we called on, just return to a different thread. And we don't really have to specify what thread it is, because that's all managed for us. But what this guarantees is that whatever happens afterwards isn't going to be on the main thread.
Okay, so it's going to say, go do this thing, but we're awaiting, which means still don't execute anything after this until I finish this thing. But I am telling you that it's okay to not return onto the UI thread.
Exactly.
Is that correct?
That's totally correct.
So it's saying previously we didn't use anything, so it started on the UI thread, went to a background thing, not necessarily a thread, but went to some task, background thread thing, came back. Now it's not going to come back.
It's not going to come back.
Okay, all right,
And
whatever
we'll see.
you say.
All right, if you don't believe me, we'll take a look.
Okay.
All right, we'll start the good threading, and then you can see that we can still open this and close it, and then it finally ended.
Okay. Now, how is it able here, the print status, to come back and actually update the UI? Because you just told me you're not on the UI thread.
Yeah, so behind the scenes, we're using bindings. So in the set property, it has an invoke main thread inside.
I see,
so
okay.
There's some safeguards by the good folks at Xamarin to help you update the UI.
Perfect. So if you didn't, I really want to clarify this. So if you didn't, so here, when you say print status command ending, in that instance, that method is being executed on some background worker thread, right?
Yep.
So if you didn't invoke on the main thread, it would blow up.
It would blow up.
It would actually crash your application.
Exactly.
Because you're trying to update the UI from the
background thread.
So that's why you always really want to be sure, right? Where are you executing right now?
Yes.
So, cool. Nice.
And that's the most important distinction for Xamarin. Sometimes .NET developers have a background with async await, but there's no concept of a main thread.
Gotcha.
It's just a thread.
Just a thread.
Yeah, and actually, funnily enough, that's the next sample. So the next one we're going to take a look at is updating UI from the background thread.
Okay, gotcha. Cool. Cool.
Yep. So moving on to this. For this one, we're actually in the code behind because we want to update status label.text directly.
Okay.
So it's the same thing. We're awaiting with configure await false because we know, hey, let's get off the UI thread.
Yep.
But then afterwards, if we update status label.text directly, bad things will happen.
Okay, I'm ready to see bad things. Yeah.
All right, so I'm gonna click this, and oh, it actually worked. Sometimes it might work. Let's try again. There we go.
There we go.
So we'll see an exception. Only the original thread that created the view hierarchy can touch its views.
Makes sense.
So I don't know why it let it before, but this time it's saying don't do that. Be sure to be on the main thread if you're updating anything in the UI directly.
Got it. So your app is now crashed completely.
It is completely
It's
crashed.
gone.
Yeah.
Out of here.
And we've seen that in the wild. So if this was in some sort of edge case, in some sort of branch where it doesn't happen often, and then that one time that it happens is just catastrophic.
Got it.
Yeah, so how to fix this? All we do is call device.beginInvoke on main thread, and then put our code in there.
Boom.
Boom. Simple as that. So all that does is it executes anything inside of here on the main thread, and we're good to go.
Very nice.
So let's take a look. And there it is.
Nice.
Updated from the UI thread.
Now, the cool part about that method, too, both part of Xamarin.forms and Xamarin Essentials, is that it does a check to see if you're on the UI thread first.
That's right.
So we handle that for you.
Awesome.
Very cool. Nice. What else?
Cool. Oh, okay. Next, we're going to look at exception handling. This is something that is really, really easy to get wrong. So we'll take a look at the bad exception handling first. So with tasks, we talked about .result, we talked about await, but sometimes you want to fire and forget. Sometimes a task can just run. We don't care if it completes, if it doesn't complete. It's just run.
Yeah, just go.
Yeah, we just need to execute something. So let's say we need to try catch, right? We're .NET developers, we use our catch statements. But in this case, what happens is because we fire and forget it, execution will continue till we're outside of the catch block.
Okay.
So if any exception happens here, who knows where it goes?
Into the ether.
Yeah, depends on how your app's structured. So let's take a look. So you'll see here command ending will print first before the exception happens. So let's take a look. That's fire and forget. Oh, actually, before that I have to restart the app because setting the status label text actually broke our binding.
Oh, interesting. Yeah, there you go. Oh, yeah.
Yeah.
That makes sense.
All right.
So yeah, previously you just had the binding set up and you just had that. Cool.
Yep. Okay, so let's look at bad exception handling. So we'll see the command ended, and then the task faulted, but we're not getting our print status exception occurred.
So that exception, which was thrown by that fire and forget, is gone.
It's gone.
No one knows.
No
so
one
your app
knows.
could have some sorts of issues. It could be even crashing, but it's like you.
Exactly.
Who knows? Got it.
This
How do I
is-
fix that?
Yeah, this is almost worse than an app crashing, right? Because with crashes, you kind of know where it is.
Yeah.
With this, it could be something layers down.
Gotcha.
Yeah, so moving on, how to fix this? All you do is use task.continuewith. So what continuewith does is once our task completes, regardless if we awaited it or not, this continuation will happen, and we can pass in an action. So we can, in this action, we have the task as a parameter, so we can inspect our task. And we can also set these continuation options where you can specify only unfaulted or only if canceled or only uncompleted.
Oh, okay.
So-
That's really nice, actually. So you can do this continuous, decide how you want to handle a continuous. So successful, don't care.
Exactly.
But if it's faulted, let me print out a message.
Exactly.
Very cool.
One thing to note with continuewith is you can't have multiple continuewiths on a single task. So if you want to handle multiple different options, then just handle them all in the same continuewith.
Okay, gotcha.
So let's take a look here. If we do good exception handling, we'll see the command ended, and then the task faulted, and we have our exception print.
Nice. Very good. So if you were logging that out to like App Center or something, now you actually get that exception.
Exactly.
Very cool.
Very useful. All right, now let's look at timing out. So how do you time out a task, right? Tasks kind of just run. What if you want to set a time limit on it? How do you do that? So the example that I've seen in the field is here, actually, task.waitAll, because task.waitAll has a second parameter, which is a timeout.
Oh,
This
that
is a time span.
seems convenient, right?
Seems
It's like
super
a timeout,
convenient.
so
yeah, I was looking through the task API. This one has a timeout. Must work, right?
Yes.
Let's try it out. So we'll see. Oh, the button's kind of jammed.
Yeah, that's not good.
Yeah. So same issue as before as .result. Task.waitAll actually runs synchronously.
Oh, so wait
Sneaky.
all. It's literally waiting all, not win
It is.
all.
Yeah, exactly.
Wait all.
Wait all. So
Okay.
anything with wait without an A, you always want a wait. You don't want to wait, and you don't want a result.
You don't want a result because those are easy to remember, kids out there.
Yeah.
Yeah.
But I'm definitely going to contradict myself later in this sample. Okay, so moving on, how do we fix that? This timeout kind of tricked us, so we don't like that. let's take a look at our good friend. Oh, actually, it's a new one. What I used to do was I would create a separate task, which was a delay, and then I would do test.winAll on that.
Oh, I see.
But in researching for this segment, I actually found a better way.
Okay.
So cancellation token source is your friend. What you can do is create a cancellation token source, and this is it's part of the TPL, which is the task parallel library, which is a mechanism to help you cancel tasks. Exactly what a timeout is, right? And it takes a delay, where you can pass in what your time span is. In this case, we'll time out after 3 seconds, and how you pass in a cancellation token. And that's where the optional parameters came in before. So you'll see I'm passing it in here.
Oh, gotcha.
And
Pass in that token.
Yeah, and I'm just passing it into this task.run right here, cancellation token.
Gotcha.
And then within the task itself, you can also throw it on cancellation requested.
Oh, okay.
So you have that fine-grained control if you want certain things to throw or certain steps to actually check.
Gotcha.
Because cancellation token will try to cancel the task, but if you just have a task that's just spinning, sometimes it might just keep going for more than you like.
Gotcha. And there's probably also the state in which you might need to pass this token down. So maybe you're calling into another third-party library. It takes the task cancellation token, and then you can kind of pass that down. They can cancel it, and then it can bubble up. Very cool.
Exactly.
Yeah.
Super useful. Works awesome for timeouts. So let's take a look. We'll just say good timeout. That's running. There's no UI lock, and then after 3 seconds, it cancels.
Very cool. Yeah.
Yeah, and the underlying task is still run, or it's not still running. It was supposed to run for 60 seconds, and then it just got canceled.
Very cool. And that's really nice too, because you were just sitting in a timeout, but I'm imagining that with that, you could also manually cancel. So maybe you have a cancel button, for instance.
Exactly.
Yeah. So if you're doing a long upload and people are like, no, I gotta go on this airplane right now, cancel.
Yeah. One useful thing that we've seen is on navigation. Sometimes if you don't want to, you want to reduce steps for the user, make it easier to use, but you also want it to be performant. Sometimes if they're doing something and they navigate somewhere else, that means they wanted to cancel.
Gotcha.
So on navigation, you cancel. They don't even have to do anything.
Perfect.
The next one, we'll look at task completion sources. So this is kind of a more complicated mechanism of task, the task parallel library. But in a nutshell, task completion sources let us make synchronous code run asynchronously.
Gotcha.
So it's a good way for us to create tasks with fine-grained control.
And that's great, because often when you're dealing with iOS or Android specific code, there's not an asynchronous method. They might have like a callback or an event, and you can sort of
or a delegate.
or a delegate, or asyncify that API. We do that in Xamarin Essentials all the time.
Oh yeah.
You'll find these things scattered everywhere.
Yeah. Once you're done with this sample, look in Xamarin Essentials and you'll understand the whole thing.
So what's this thing doing here?
Okay, so let's take a look at the good one first, actually.
Okay.
So first, we'll look at what a bad task completion source looks like. So we're asyncifying this API, but sometimes we'll look in this method. There's a lot of code here. I won't go into all of it, but the gist of it is internally you have a task.run where you set result.
Okay.
So this is almost the most important thing with a task completion source, because if you never set the result, the task never completes.
Gotcha.
So if we take a look at the bad example, so what happens is in here, I'm making it run 10 tasks with winAll.
Okay.
But these tasks, before they're completed, they'll throw an exception. So what happens then, right? If their task completed, then it's fine. But if it throws an exception, how are we handling that?
Oh, it'll never get returned.
Exactly.
Because you never reset it.
Yeah,
through an
never
exception.
set an exception.
Gotcha.
So let's take a look at that. We'll see that these tasks actually are faulting. So the task faulted, but our exception here
Was never printed.
is never printed.
Gotcha.
So
And that's bad, because now it's just, again, into the ether.
again, into the ether on multiple tasks.
Gotcha.
And then because we never set the task completed, then the task might run forever if it doesn't fault.
Oh,
This is
gotcha.
faulting, so it actually has a safeguard.
Gotcha.
But otherwise, who knows?
Who knows?
So to fix that, what we do is in our new method here, All right, so here in the right way, we'll see this is a different method, similar to before with all the structuring and harnesses, but in the test.run itself, instead of just setting the result, we actually have a check on a cancellation token. If it's canceled, we need to call try set canceled. And then in an exception case, we have to try set exception.
Makes sense. Handle all the cases in which it can possibly go wrong.
Exactly.
Gotcha.
And then this way, we're totally safe. Any edge cases, any exceptions, we'll handle them. Any cancellations, they're all covered.
Very cool. That's nice. It's nice to kind of see that, and it also prints out the faulted task and the state and everything that you would need.
Yeah.
Very cool.
So
and all the exceptions.
Exactly.
Yeah.
Oh, and a funny thing with the exceptions too. So in our view model, we actually have a try catch around the when all.
Ah.
So this one gets us the exception, but it's only the first exception that occurs out of all of the tasks.
Oh, I see. Got it.
So here we'll see if we print x.message, that's only the first one. So what we have to do is we have to check on each task what the exception is, if any.
Got it. Got it.
So that's kind of a gotcha. That's really, if you're not looking for it, it's really easy to miss.
Makes sense. Awesome, Dean. I love it because these are things that I can apply to my app today. Now, I know you have a lot more, so we should probably take a break and come back for a part 2 advanced. How do you feel about that?
Sounds great.
Awesome. Well, thanks everyone for tuning in. Dean, thanks for coming and showing this off.
Thanks for having me.
Now, don't forget, in the show notes below, we'll have all the links to the documentation, all the things you need. You can also go to aka.ms/Xamarin Best Practices for everything in this series. So thank you so much for tuning in. I'm James Montemagno. This is The Xamarin Show. Have a good one. Hey, James here. Just wanted to check in and thank you for watching this video. Now do all the things that you know you want to do, such as like, subscribe, and ding that notification bell to become part of the notification squad. While you're here, check out all these awesome videos that I've already recorded. Click on that thing. Click it. Watch it. Do it.